Hello, can you hear me?
Yes, ma'am, we can.
Okay.
A warm welcome all of you to the 4th day of Science Leadership Workshop. So we are starting today with Professor Shobhona Sharma. Professor Sharma is based at Department of Biological Sciences, Tata Institute of Fundamental Research in Bombay. And she is specialized in immunology, malarial parasite, biophysics, molecular biology, and biochemistry. She has had a fantastic career, and she's actively working on this malarial parasite. She's very well known for her research contributions in malarial parasite. And she's elected this in Bangalore and Indian National Science Academy, that is in Department of Malaria Foundation in the United States, and lots of awards, especially so many first author papers in Journal of Biochemistry. I have actually had a look at her career, and she's also actively involved with matters, for example, ethics in science and women in science. And in the morning mail, I have shared her PowerPoint slide as well as her article published in INSA about ethics in science. Especially, I instructed you to read her works on the women in science. So today she is going to speak us about science leadership in general and on a focus on women in science. So warm welcome to Madam. And along with me today, I have Dr. Monisha Thiman. Professor Thiman is working as a professor in Department of Microbiology and Biochemistry, Central University of Punjab. She herself is a young science leader. Over to you, Dr. Monisha.
Good morning, everybody. Good morning, ma'am. It's our pleasure to have you here with us today, and I welcome the participants who are eager to listen to you, and I'm sure that it's going to be an enlightening lecture, and so looking forward to hear you, and over to you, ma'am.
Yeah, first of all, I would like to thank the organizers for including me in this workshop. I'm delighted to be a part of it. I am going to share some of my experiences and also give some opinions about road to leadership positions. This is what I am calling my talk, and this is what I have entitled my talk. So can I have the first slide, please? So you can see that I have shown, like Ram Ramaswamy, a switchback photograph of, how to climb to the top. But essentially, I would like to say that almost everyone in science is a leader. Can I go to the second slide, please? My phone is slow, so I'm not sure whether the second slide is on or not. But I can...
yes, it's on.
Yeah.
Yes.
Yeah. So this is, the question for a young researcher is how to develop leadership qualities. And the question for a senior researcher is how to inculcate leaders. And essentially, I will discuss general points with some of my experiences thrown in. Specifically, there'll be some emphasis on challenges faced by women scientists. And to begin with, I would like to start with the life of a young researcher. So can I go to the next slide, please? So first of all, each principal investigator in science is a leader because he or she has to lead a team towards answering a specific question, scientific question. So the important factors are questions and tools. I used to describe scientists to my daughter as blind men who are looking at an elephant, and that it's a common story about how one scientist says it's like a rope because he's looking at the tail, and the other one says it's like pillars because he has just found the legs and so on. My daughter didn't believe it. She had a much more esoteric picture of a scientist. But nevertheless, I think there is a lot of truth in these analogies. And therefore, tools are important so that you can have an overall vision. The questions are even more important. So I have a friend who in the days of uh, some 5 years back, when plan money started drying up, said that he's quite upset with the present system, but nevertheless, to beat the system, he'll start working on the lotus flower. Now, obviously, lotus flower, because BJP had just come into vogue, and he thought he could get a lot of money that way. But those are frivolous questions, really. I think we need to ask very important and challenging questions. Now, in today's world, for instance, any question on COVID-19 is very valid question. But in terms of scientific research, of course, we all have our favorite subjects, favorite questions, and translation is one of the things that needs to be looked at, but is not, to a passionate scientist, a deep question is what matters. Now, in terms of leadership for masters and PhD students, I will come to their status later. Let me start with young researcher. So these points were actually mentioned by the organizers, and I have just lifted them from suggestions of the organizers. All of them are obvious. I have made bold fonts for creativity and innovation, because that, I think, is one of the key and most important questions. Time management, risk-taking, decision-making, and collaborative teamwork. Now, this is again where leadership shows up, because if you want to answer a question, there are many aspects, and clearly collaboration, interdisciplinary work is absolutely important. For your own team, the leader has to be a good mentor, has to be actively listening and showing empathy, allowing flexibility, problem solving and conflicting resolution, and most important, delegating, because delegation is what matters most. You delegate different aspects, and essentially you allow team members to do different parts of the work. Okay, is that okay?
Yes, ma'am. Everything is fine, please.
Hello.
Yes, ma'am. It's fine, ma'am.
Yeah. Next slide,
Yeah,
please. Can I go to the next slide?
Yes, ma'am. It's slide number 3 now.
Yeah. So this is called My Science, and that's because I just wanted to give a brief flavor of what kind of work I have been doing. I have been working on the malarial parasite for the last 30 years. And my main question, the starting question was immunity to malaria, can we make a vaccine? Very simple, very practical, very emotional question for India. But early on, I realized, our group and many others, we realized that it isn't easy to get a vaccine. We have been working with malaria for over 130 years, and we still don't have a vaccine. And that is mainly because the parasite knows the host system and can divert the immune response and doesn't allow a long-lasting immunity. So it's important to understand immunity, and therefore, soon within 10 years, we started looking at the basic biology, immunity, how does it happen, what are the parameters, etc. During the course of the work, we also meandered into red cell membrane biology. This was in collaboration with physicists using optical trap. We worked on metabonomics with using NMR as the tool. Um, we also looked at immunomodulation of neurogenesis in complicated malarial infection. Now, this is a very delicate line of work because uncomplicated malarial infection was considered to be not at all important for the brain functions. The cerebral malaria infection is of course, it affects the brain and it definitely affects the brain. But we find very important and observation on the immunomodulation. Basically, we find that if you get during the malarial infection, your brain is impaired, but it reverts back. It's very elastic. It reverts back immediately. But this is for adults. Juvenile malaria actually causes long-lasting anxiety, and that is something very new, and we are writing this up. The current phase of work which I'm carrying on is nanolipid carrier-mediated drug delivery. This is in collaboration with Institute of Chemical Technology scientists. And this is like a translational work, which at the end of my career with basic research, I feel that I really need to give something, and it works very well. The nanolipid-mediated antimalarial drug, the ACT, works at 1/5 or 1/10 the concentration, requires far less medication, one dose per day rather than 4 tablets per day, and so on. So the compliance is likely to be much, much better and will cause much less side effect for the malaria. So that is what I'm pursuing now, and we are collaborating with the industry to make it work. Next slide, please. How did I get here? So next slide. I will briefly talk about my school and college life because this is where the foundations get laid. So I received strong support for academic proficiency from my parents. Who doesn't? All parents want their children to be educated and for them to do well in their school. We were three. In those days, academic proficiency was the thing. One couldn't go for any other career vocation. Those would be looked down upon and frowned upon, music or dance or sports. But I'm glad that in the current situation, those are given weightage to quite some extent, not as much as one would like, but definitely much more. We were 3 sisters, no brothers, and therefore there was no real scope for sibling gender discrimination, but that does happen socially in households even now. We lived in a protected existence. We were residing in Delhi and safety for young women was an issue. This closes many, many options. So you can't just go for music lessons at night or anything, any sports activity, etc. Career choice. Expectations from parents, society, and peer group. This is something which is so overwhelming. Even now, expectations from parents are that you should settle down. And this for men means a big package in whatever field you want to take up, but a good package. Society is more or less the same. The peer group decides what the current trend is, and that has its own effect. For men and women, this is slightly different. For women, one of the career expectation is marriage, unfortunately. Marriage with the career, with the professional career as a side task. That's very unfortunate. Nevertheless, that expectation remains. The only line of work which allows, which makes parents comfortable, I gather, is the IT line where the woman can work from home, is safe, has flexi hours, etc., etc. Other fields are okay. Doctors, engineers have always traditionally been okay. Scientists, all right. IAS officers, yes, perhaps. But many other career expectations are looked down upon. Let me move to my PhD and postdoctoral life. Next slide, please. And here I want to emphasize that my joining PhD program at the Tata Institute, so I did my PhD at Tata Institute, went away for a postdoc, and came back as a faculty member. So I really have been long time at Tata Institute. But joining that was quite a task. There was strong opposition from my father. He objected away from home for young girl, corrupt city, etc. So I had to fight a lot to get this, to go and do my PhD. But I was supported by my mother very strongly and eventually did manage to join. I enjoyed the academic and intellectual environment and the safe habitat of Mumbai that gave excellent fuel for growing into a thinking and independent scientist. My career trajectory has been somewhat funny. I did my master's in physical chemistry, Delhi University, PhD in plant biochemistry, molecular biology unit, Tata Institute, and then went over to malarial studies for my postdoc. How did that happen? This happened because Obaid Siddiqui, who was the head of MBU in Tata Institute, he essentially suggested that I join a lab while I was looking for a suitable nitrogen fixation lab and was actually having a dialogue with them for my plant research. He said that there was this Nigel Godson who had worked with Fred Sanger and is really very good at molecular biology, recombinant DNA technology essentially, and was looking for a postdoc. So he said, while you're trying to manage these other fellowships coming, why don't you go there and for 1 year work with him? And I said, okay, maybe it's a good idea. I'll learn a lot of molecular recombinant DNA biology, molecular biology. So that is when I went to NYU Medical Center. Next slide, please. So my postdoctoral fellowship was at NYU Medical Center. And this was in collaboration with Ruth and Victor Zweig, who were established parasitologists, and Nigel Godson, who was actually looking at the parasite from a molecular biology point of view. And the first malarial gene, CSP, was cloned in this lab. And it is currently the only malaria candidate tested in the field. And experience in this field in his lab was fantastic. Then, since I wanted to continue with the vaccine studies, I decided to go and do a postdoctoral fellowship at Ron Corley's lab, whose lab was a standard immunology lab. And we worked with B cells because I wanted to know about antibodies and essentially how do B cells get committed to one particular antibody production? Can we enhance that? For my PI phase, I joined in TIFR in 1987, and I was excited about the possibility of a malaria vaccine, but extremely naive about epidemiological data in India and the samples that I would need for this kind of work. Also, the group sizes were very small, 3 to 4 for the first 4 years. My first student was Cheryl Lobo. Next, please. And my first project was essentially looking at differential immunoscreen using sera samples from patients and immune persons from endemic areas. We had a lot of problems of acquisition of samples. Mumbai hardly was endemic. It had something like 200 cases per year at that time. Also, we were looking for malaria immune adults. How do you locate them? So essentially, you have to go to endemic areas like Orissa. And of course, I had to approach collaborators. There was no way I could go to Orissa and collect field samples in those days. This, as Shubha pointed out yesterday, was in India where emails didn't exist. Telephones could be used, but were very expensive and very unreliable. And the main mode of communication were letters, snail mail. Nevertheless, collaborators who provided endemic samples, patient samples were easier to get. We got them from all over India, including Orissa. And the first paper that we published, that was Cheryl's work, was looking at a differential immunoscreening, which made use of molecular biology expression libraries and using immune and patient sera because I was convinced that immune people have some antibodies which are unique and characteristic. Now, this paper, I recall, it was, we tried to publish it in PNAs, and the reviewer, Traeger, he actually said, Bill Traeger, he actually said, clone complete genes for 2 of these and I'll publish it. The paper looks good, everything else looks fantastic, but partial sequences will not do. Now that was a big challenge. No PCRs those days. So essentially one would have to screen genomic libraries or cDNA libraries and keep walking till we get the full gene. And these were unknown genes at that time. So there was no way one could look for homologies. Databases had barely existed in those days. So as a result, I actually decided that we'll go ahead and publish in this very standard journal of the field and get along with it. But it's a paper which has really formed the basis of our much of our research. So next slide, please. Can I be heard clearly?
Yes, ma'am, you're fine. We can hear you. Thank you.
Yeah, it's good to have a feedback once in a while because my
Okay.
screen is not so good.
Yeah.
Okay,
We are coordinating
so
fine.
this is slide number 10. Yeah, okay. So this is the differential immunoscreen, which led to many parasite proteins, amongst which were, so I've put some lists, but a ribosomal protein, which has forms a good body of our work. And I still think some of these ribosomal proteins, which are really ancient proteins, evolutionarily, they perform multiple functions, including going on the surface of the parasite and doing strange things. And they are good drug and vaccine candidates. We need to learn much more about these and see. So I have a couple of patents on these, but to make it into a drug or a vaccine target really means much, much more work. So I'm sure the world will look at it. So coming back to biology of malarial parasite, I have already talked about these fields. I have, published some papers with so many grants and collaborators, PhD students and masters. So what? The basic research will continue, whether I'm there or someone else does it. But this commercialization of nanolipid carrier mediated drug delivery is something that I'm extremely excited upon. It's a translational aspect of our work. And I do hope that within some years, we will be able to use these. The current industry which has taken this on And so initially we had a lot of difficulty getting companies to come for this because Novatex, for instance, which sells the anti-malarial drug, they weren't interested, I think mainly because dose reduction would mean, a completely new production, a new loss of material, etc. It's also a disease which doesn't pay too much, and these are called neglected diseases. And we were really trying desperately to work with some of them. While we were doing that, a company, Bliss GV, which actually has a base in Africa, and they were extremely interested. So, so this is where we are taking it forward. Next slide, please. So I'm just listing some of my collaborators. I must acknowledge them because without them, our journey would have been quite different and extremely incomplete. More important are students. And although I have listed Cheryl, I talked about her, she was my first student. I've had huge number of students, masters, visiting students who have done wonderfully well, postdocs, and so on. So I'm going to just show the pictures. They are really extremely, most of them are very passionate. Some of them have gone into different lines. So Sudarshan, for instance, has gone into intellectual property rights. And many of the master's students have gone in other lines, which I think is in some way fulfilling because diversity is a required parameter. So coming back to the so slide number 15, coming back to the basic tenets which were already listed about how or what properties one requires to become a successful leader. But in this, I'm going to now emphasize the women in science part. So we have a lot of, next slide please, we have a lot of basis for discrimination and they are all listed over here. Unfortunately, we know that these still persist because we hardly have communities other than upper caste Hindus amongst scientists. There are of course exceptions. There are but all religion is not equally represented, nor are ethnicities or minorities represented. And of course, I don't even want to get into caste discussions, but let's go into the gender discussion. And if we go to the next slide, slide number 17, we have the overall position of India as pretty poor. This is essentially 108th position as per Global Gender Gap Index of 2017. These were scored using educational attainment, health and survival, economic opportunity, and political empowerment. Of course, my talk will emphasize educational attainment, but let us look at political empowerment. Next slide, please. In Indian Parliament, we hardly have representations, right? We've been having discussions about quotas and so on, but nothing seems to be there. So currently we are of the order of 14% in Lok Sabha seats. And this is a slight increase. This is 2019 results. There's a slight increase from 2014 polls where we had 11%. I've written a few points about West Bengal and Uttar Pradesh having elected the highest number of women MPs. I think this is because the leaders are powerful women leaders, but some of this is very incidental actually. One would definitely want to see it go to 50% as soon as is possible. Let's move over to education. That's the next slide. So the STEM field, We know that women comprise a minority of the STEM field, and biology is the best, but even there, the representation change is very, very slow. So let's go to some data, which is slide number 20 at the school level. Not much difference actually. If you look at the total numbers, it's pass percent is essentially better for girls than for boys, because 89% of girls pass as opposed to 79% of boys. At the next level, which is the next slide, we look at basic, undergraduate and postgraduate numbers, and these are pretty equal. At the postgraduate level, there are about 70 female students for every 100 male ones, but I think that is not a very big difference. Let's go to the next slide. This is where higher education comes, Master of Science, and that's also pretty equal. For Master of Science, I put an arrow, and it's 1.6 versus 2.3. So there are more female students than male students at the Master of Science level. This is, of course, as I said, the boys go for packages which come with other career options. So for pure science or technology for that matter, which is also, well, if you look at bachelors of engineering, of course, there are many more boys than girls. But let's go to next level. If you look at all the faculty, and this is compiled from MHRD report, if you look at faculties, the numbers have, barely changed, I would say. For overall faculty members, it's not bad. It's 49%, which is pretty in 2013, which is pretty, which is ideal essentially. But if you look at full professors, it's 31%. And if you look at all full-time faculty, 1993 to 2003, it is about 16%. And we know that there is a big gap over there in terms of numbers of women representations. Next slide, which is slide number 24, which shows the distribution in terms of different kinds of organizations. So here the point to be noted is that institutes of national importance, the number of women faculty is strikingly low. At many places, it's not too bad. If you look at central universities or central open universities, it's quite close to ideal. But for National Institute of National Importance, there seems to be a bias for not absorbing women. So what were the challenges faced by me as a young woman faculty? That's the next slide. If you look at it, the most important was a lack of proper mentors. I must say that there were no discriminations faced, and that's listed in the right-hand side column. Recruitment, pay, freedom of research topics, intramural funds for research, capital equipment usage, general material benefits, student allocations. There was absolutely no discriminations faced by me. And that I would think is true for most institutions. However, for the major challenges were lack of time for networking. That is very essential for the success of a scientist. You need to network. People need to know what kind of work you're doing. I mean, this is not an ideal situation. One can say my work should stand for itself, but very often people don't know. So you have to make them know. Lack of sensitivity. For instance, timings of meetings, being called at times which is very inconvenient for a woman faculty. Uh, they have to go home, they have to take their children out of creche or whatever. Then there are problems during pregnancy, problems during young motherhood, and that shows up in lack of facilities. For instance, childcare, toilets, and these amenities at the place of conference, meetings, field stations. So these are very well-known problems and unfortunately are still not taken care of uh, properly. What is the way forward? Next slide, please. Slide number 26. Um, we can talk of reservations or the quotas, but that in science is not a good idea at all. There are many, many capable women, and so one really does not need reservations. But what one needs is greater opportunities for research exposure at all levels. Also, as a researcher, to be in responsible positions. So this is like the Indian panchayat. I mean, earlier women would never be a panchayat leader. And once reservation came in, people would put their wives or their other family members as pseudo representatives. But in many, many cases, these women then realized that they could make a difference and they took over and they worked on their own and did fantastically well. So when a responsibility is thrust on you, I think most people who take it up do a very good job. And that happened to me as well. Shubha had mentioned that I was chairperson of 6 different aspects at one point. And every time I would know I had too many things, others would say, no, but you can do it well. We trust you. We know you put in a good bit of effort. And that trust went a long way. And I think one could really do well in many of those aspects. And that is an eye opener. The proactive recruitment, I think, should definitely be practiced. Sustained facilities to support women faculty, I have talked about it. But most important is sensitivity and awareness. I think in our department, for instance, in TIFR, we did well because we were so many women faculties. So the sensitivity was natural. And that was not something that had to be imposed on others, on men, which is not true for other departments where men are just aware of those problems and they actually take it well if you point it out. But if you are in a minority, sometimes women feel very embarrassed pointing out certain problems. Lack of toilets, for instance. I mean, it's not something you would want to drum it on people, uh, but when you do it, it really works well. And I think Shubha, for instance, did a fantastic job of it when in TIFR, because there is always this expectation that there'll be fewer women, so fewer toilets, fewer facilities is a very standard one, and we have to overcome that. Next slide, please. So this is more or less my last slide. It says properties of successful leaders. That would be to develop excellence in the field of work, to be able to have short and long-term vision. Vision is absolutely important, very important for executing or defining a goal. You have to be willing to take a risk and shoulder the responsibility that comes with it. And as I have said earlier, delegate work to team members and trust them to deliver. You can interact with them all the time, but let them do it and surprise you. Many people surprise you, actually. Many people are born leaders and do it very, very naturally. I am a little bit of a reluctant leader. I'm pushed into leadership positions more often than not. But there are many who are who would who would love to do such work, and we would love to get complete freedom of work. So thank you for listening to my talk, and I would love to have questions.
Thank you very much, ma'am. It was really a very good and enlightening talk. I'm sure participants will be having a lot of questions. Can you hear me, ma'am? Am I audible?
Yes, you are. Yes.
Okay. Okay, so very nice talk, and I must just briefly, I made some points, and I was really happy because I have worked on Trypanosoma cruzi, which is another neglected disease. So I was working on that, and I understand how difficult to purify a vaccine candidate, and you get one protein, and then you purify it, and doing it in 1994 and publishing it that time, that's something amazing. I must, that's something really a big thing. I mean, we cannot, right now the students in 2020 think that, okay, cloning and all those things are so easy. You just get some kits and you do and finish it. But publishing, thinking of PNS in 1994, that itself is a commendable job, you know. Okay.
Yes, thank you very much. Those were very challenging days, and it was quite difficult to do the work, but it was very enjoyable because in those days everyone was going through those difficulties.
Yes. And a second part, because your talk was very nicely segregated into two sections. One was about your work, and second was about gender discrimination and gender biasness in work and academics. So I could correlate your no discrimination in recruitment, pay, that straight away goes with me. I mean, recently, like 6 months back, I've been promoted to professor. So those things are absolutely, I could correlate that with myself also. And challenges, absolutely correct. Sensitivity, facilities. When we joined here in Central University of Punjab, my daughter was 4 years old, and we came from US. So first thing, Vice Chancellor asked me that what you people need. So we asked for a creche or daycare in the university. So within 6 months, we could establish that in the university. So yes, facility-wise, if we can develop things, so those things we can do wonders. Women can do wonders in work. So thank you very much, ma'am. And your suggestions are again very great. So with this word, I am really very thankful. I'll take some of the questions which our participants are having. I am too excited to give my thoughts about it, but we have a lot of questions from the participants. So first question I'll take. Pramod Sarkar, he's asking that young people can be team leaders in general management, but in academics, it's very rare. Why?
I think, I must say that scientists, it is considered that scientists are very rational, liberal, free people, but it's not. I'm sorry to say. So people who sit on, this is like saas bhi kabhi bahut hi kind of business. People who have reached the top, since they have taken so much time and stress, that they essentially don't want to give it so easily to younger people. But times are changing. I think if you do excellent work, and if you come up with ideas and pursue them, initially they may not be received very generously, but if you pursue them, it does work. That child care center which I finally got going in TIFR, I had tried doing it when I had joined, but I was told that I have to get at least 25 working women all over Mumbai who will use it, and that itself killed it, because who would carry a child in a crowded train and come to TIFR and use the child care center? But 15 years later, we could show that there were on campus 25 people who would want to use it. And the then director, Shobho Bhattacharya, was very, very keen about it. And so circumstances matter a lot. So you have to keep persisting, and hopefully things will change with time.
Yes, thank you, ma'am. Dr. Felix, you can take the next question.
Yeah, so we also have Professor Shubha Thole on the panel. So in case you would like to ask someone, you're welcome, ma'am. So I would like to pick up a question here through, yes, go ahead.
Yeah, so Shobhana, in connection with the childcare center, do tell us how you overcame the battle of the home care situation, how people didn't want to remove their children from these home care aunties. And
yeah, those were difficult days. So the problem was that, you would, as Shubha points out, I mean, people would have a nanny at home who would do all kinds of work along with childcare, and it was so much cheaper. So we had to prove that the childcare center had quality service, that there were activities which were worthwhile, and so on. So it's always the proof of the pudding is in eating it. And I guess you have to have faith in yourself that that can be delivered.
And you were also,
yeah.
Sorry, you were also creative, no, Shobhana? So there was this auntie who had 6 children in her house being taken care, and you solved the problem by recruiting her as a teacher so that she brought her 6 children with her. I mean, this was brilliant.
Well, one has to make use of all resources, and I must say that all faculty members in TIFR helped in their own way, and there were many people who came forward, became volunteers, and so on. So ideas came from many people. I must say that these are not my original ideas, but I suppose this is a property of a leader to listen to everyone and judge and take quick decisions and do them. So
thank you, ma'am. Okay,
ahead,
we have another question from Swastika Mathur. She's asking, have you ever had this thought that if you were male, you would have progressed better?
I'm very happy that I'm a woman. If I was a male, I might have joined engineering or one of these very standard occupation and gone for a package. Who knows? So as a scientist, I'm very, very happy that I'm a woman, and that of course all my family members have been very supportive. You need to convince everyone in your sphere that what you're doing is important, including your children, that what you're doing is important, and that continuing with an attempt to excel is certainly worthwhile.
Thank you, ma'am.
So no, I'm happy as a woman.
Yes.
Yeah, it's amazing talk, ma'am. Yeah, your vignettes of childhood days in the gender, and especially you talked a lot about the education sector. It's amazing talk. I was totally enjoying your talk, although my internet connection is really flaky today. So I thank you so much for this wonderful talk. It's really a privilege to have you here. Let me pick up one question here from the pool. So this question is by Dhruv Kumar. People in the scientific community in India do not allow the scientists who come from no big contact or no networking. Do you think big contact suppress the science leadership quality?
So, okay, this is a real problem. Partly because networking is considered important, and it is expected that so these days people are very savvy. Even in school days, they link up with institutions, they go for summer projects, they try to learn from their experience. However, I must say that in let's say a competitive field, let's say interview for a PhD studentship, I think the good places still look at people from all over India, not necessarily, the established organizations. For faculty recruitment, I think there are written down or maintained norms for most institutes, and some of them are correct, some of them are not so obvious. I mean, it's not something that you can just tabulate so many papers, so much H index, etc., etc. But if your work is good and you can, it'll come out in your interview, and I think it should do well. Have I answered your question?
Oh
Yes,
yes, absolutely.
yes,
Yeah,
yes, yes,
that is
ma'am.
fine. The question itself is ambiguous. Definitely, there are multiple ways to see the same problem, isn't it? Yes.
Mm-hmm. So
So
the
we have,
people coming from, sorry.
please, yes, ma'am, please go ahead.
People coming from places which are not known is a problem. This is what I was saying, that if you do not network, people do not know what you're doing. So it is up to you to communicate to some extent. You can be ideal and say, they should notice my work, but the world is not ideal. So it is important to show what you're doing, to tell people what you're doing, or what you want to do.
Yes, ma'am. And I really agree. One of your point was that I think that we need that trust. We need to build. A women need more time. A female faculty, we need to, if a male can do that in 1 year, we have to prove we actually have to prove more than a male. That I think you also agree to it. And I also know that we need to prove more than what a male faculty or a male recruit do. So I will take some of the questions from immunology and malaria, because one of the student participant, Nikhil Hota, has asked. He's from Koraput, Orissa, and they say that it's very, very, the most of the people, about 99% people in that area gets malaria. And he wanted to ask that, do people get resistant to this gradually, first? And second, is malarial eradication is feasible in India? So he has 2 points because he's from that area. So he wanted to know about the resistance and eradication of malaria.
So I'm sorry I didn't get the second question, but I'll answer the first question. Koraput is one of the endemic areas where people, which is a true endemic area. That is, there are year after year reinfections, and after several reinfections. Now this number is not very established, but it is understood to be in the range of 6 to 12 infections, that people develop a special kind of immune response, which then makes the person immune to the disease. The parasites still maintain. You see, evolutionarily, they would like to be transmitted. So these people are not free from the parasites, but they show no symptoms of malaria, and they are actually healthier than the uninfected population. So yes, that resistant word is very, very general, but it is called naturally acquired immunity. Okay? And most African places this happens, and in India, very select few places. And Koraput, Sundargarh, these are some of the areas. There are some in Madhya Pradesh, Maharashtra as well. Northeast, a few pockets. But such endemic areas are not abundant in India, and therefore people remain non-resistant, if you want to call it, for years. I didn't hear the second question. Can you repeat?
He wanted to know that whether it is malaria eradication is possible, it's feasible. Can we expect sometime in future that it will be eradicated?
So yes, the short answer is yes. And that is because we have drugs, we have mosquito control measures, and it is mainly a question of economic resources and awareness. Most of the Western countries had got rid of malaria, but they still have mosquitoes. They are a different ball game. And whenever people go with malarial parasites, these mosquitoes can pick up and infect some of the people. But they have very strict quarantine rules over there, so that those are taken care of very, very effectively. Um, if we can reduce this reservoir over time of the parasites, we can certainly go to a point where they'll be eradicated, like smallpox and polio. But because mosquitoes are so resistant that mosquito-borne diseases have been most difficult to control, parasites are by definition, organisms which live on the host or the mosquito, and they have been doing so for years. So they have they have learned to live with the host in almost a symbiotic state, if you ask me. So the immune persons are those kind of people, but we can eradicate malaria. Yes.
Yes, thank you, ma'am. Dr. Felix, you have.
Yeah, my connection is really bad, but still I will try to ask you one question.
Okay,
Sanjeevani Bishwar is asking, there was some news about effectiveness against COVID-19. Is there any chance, even at 0.001 probability, that the vaccine for malaria will work for COVID-19? Yeah, another technical question.
There is no vaccine for malaria itself.
Yeah, of course.
So COVID-19 vaccine. So COVID-19 is a very special situation because it's suddenly hit us, and it's like a horror film. So we have all gone into this quarantine and not be able to do our regular work. So therefore, all kinds of research is being encouraged, and many vaccines are on trial. But these vaccines will have problems. I mean, right now there's a lot of funds going into it, and maybe, I mean, miracles do happen once in a while. Maybe something will happen, but these viruses change very quickly, which is the reason why we don't have a vaccine against flu, effective vaccine against flu. You have vaccine against very specific strain of flu. Now, if the COVID-19 mutates, and we know that it is mutating all the time, by the time we come up with a vaccine, that vaccine may not be applicable. But certainly, I mean, there is no other, the only other avenue is to develop suitable drugs. And that again, for a virus has been done. So,
okay, thank you, ma'am.
malaria vaccine will not work against COVID.
Over to you, Manisha. Yes.
A similar kind of question was asked. So you have already asked Ravina Pai's question, who was asking about developing a vaccine against malaria. So you have somewhat answered your one of that query again in your previous answer. So
yes.
I have one very interesting.
Let me just add.
Yeah, you can add on. Yes.
Yeah, I would like to add a point that there are some vaccines on trial, and they are effective to the extent of 30 to 40%. Now, for a regular vaccine, unless it is 90%, we don't accept. But because so many children die in Africa through malaria, that even the 30 to 40% is worthwhile in that scenario. In India, not so many people die of malaria. So a 30% or 40% effective vaccine would mean 100 people take the vaccine and go through all the courses, and only 40 are protected. So that's really unacceptable in terms of vaccine.
Okay. Thank you, ma'am. So we have Rekha, who is asking about effect of antimycin is quite known, but what about nanoparticle mediated antimycin drug effect? Is it something going on, or is there any?
So nanoparticle mediated drugs are slightly questioned because people have used microparticles, and we know that these get eliminated easily. And nanoparticles require extensive clinical investigations to make sure that these don't remain in your system. So other than cancer, I think nanoparticle mediated drugs are not uh, at the moment being used. So which is where we need to do all the research and show. So like our nanoparticle is a lipid mediated nanoparticle. It's a natural lipid, and but still we are injecting it into the host. So one needs to, we have done the toxicology studies on mice, and they are perfectly, they've shown very good results, but one has to go through proper clinical trials to make sure that these have no long-term problems. That remains a challenge.
Over to you, Dr. Felix, if you have some. Okay, maybe Dr. Felix, he was saying his internet has some issues. So I'll ask the next question. Binny Mary, she is asking, how do you feel when you changed from plant biotechnology to immunology?
Sorry, come again.
How did you feel when you changed from plant biotechnology to immunology? You know, somewhere you mentioned that you did some plant biotechnology.
Yeah, how did it feel? So so I think I have been fairly open to this. My education was physical chemistry and in college, and so for 5 years I had no biology training. So it was all what is called PCM, physics, chemistry, maths. And still I had a lot of fascination for at that time all the molecular biology studies that were going on. So I had no problems going into molecular biology. In biology, it is easier to go from a quantitative field like PCM to bio, because bio has much more information, so you need to read and assimilate. The other way around is more difficult. If you don't have training in mathematics, advanced mathematics and physics, to go into quantitative field is more difficult, and which is one thing I keep advocating, that all bio students must continue to train in maths as well, because it's really very important. And going into immunology was an eye opener. I still don't think I have all the jargons that I used in immunology. Bio uses a lot of jargon. I think that is something that puts off people who are not used to jargons. But I think the question becomes important. So if I want to make a malaria vaccine, even though my technology, my expertise at that time was molecular biology, recombinant DNA technology, I had to understand immunology to be able to make a headway. So you pick up whatever tools you need to pick up. And even though you could make do with collaborators, you need to be able to enter into their fields to some extent, because otherwise you don't know what they are talking, and that can be quite negative actually. I mean, you can't delegate to the extent that the other person will do whatever and you have no clue of what that person is doing. That is not acceptable. So I picked up, I didn't have any problems. I think many of the scientists who spoke in this leadership field, many have moved from field to field and different technologies. And you do, if it is required, you do it.
And the key is that whichever field you choose, you give your best and do your best.
Yes,
so that's what
yes.
Is important.
It's important that
Yes,
you become excellent, such that when people want to look for experts in that field, they will come to you. I think that is a lesson you must all try to assimilate, that whatever you do, it doesn't matter. Studying the lotus is perfectly acceptable, but then you should answer a problem which is amenable, and then people should come to you saying that, oh, you are the expert in such and such field, so tell us.
Okay, Thank you very much, ma'am. Dr. Felix, you need to.
Yeah, it's
so
really nice of you. Over to you. You can start.
Okay, thank you very much, ma'am. Thank you very much, Dr. Shobhana. It was a great talk. I'm sure that participants, they enjoyed it a lot. And coming straight away, the way you started from your school, your family, we can straight away correlate it. And then coming to the professional background, so everything was so perfect that yes, it was really illuminating. And I'm sure looking forward to have a career like you. So thank you very much, ma'am. And thank you for your time. Thank you, participants. It was great. And I can see so many questions coming up, and the participants were really very happy because the kind of questions they are showing.
So let me tell you, I'm a little old-fashioned, and I don't have a Twitter handle and so on. But my email is open. People can, and now I have a little more time. So if they want to email and ask questions, I shall be happy to answer.
Oh, thank you very much, ma'am. So you are most welcome. Ma'am has again given another opportunity to interact with you all. Thank you very much, ma'am. Thank you very much. Thank you.
Thank you.
Shubha Tole, would you like to add some points?
No, I thoroughly enjoyed it. I mean, I've heard elements of Shobhana's story before, but this gave new angles. And I mean, Shobhana is one of my mentors and role models. So it's just another opportunity to say thank you.
Thank you, Shubha. I enjoyed your talk, as I said yesterday morning. And I wish you all the best. And
yeah, thank you so much, ma'am. It was really wonderful, absolutely fabulous. Thank you so much from bottom of our heart. Yes, it was really nice talk, and on behalf of Central University of Punjab here in Bathinda, and also on behalf of all the three science academies where you are also part of, and also in NIAS. Thank you.
Technology has been too much, right?
So meet you all at 1 o'clock, and our next speaker is Robert Lepnis from Germany. So I will see you all at 1 o'clock. Enjoy your lunch, and I will see you all. Goodbye for now.